Good day to everyone. Our focus today is the idea of ellipse. Now last time, we've been discussing the idea of the parabola, the circle, that is, of course, those geometrical figures are the result of the intersection of a cone and a plane. So that when a plane intersects the base, or when a plane intersects the cone, which the plane is perpendicular to the axis of the cone, now the geometrical figure that is created is circle. Now, we've been saying last time also that when a cone is intersect by a plane, and the intersection is parallel to the edge of the cone, the geometrical figure that is created is a parabola. Now, the next thing that we're going to look into is the idea of ellipse. How is ellipse created? The ellipse is created when a plane intersects a cone like this one, and that the intersection is diagonal from one edge of the cone to the other side of the cone, and that the ellipse is created. Okay? So meaning to say, when it will cut by the plane will cut the cone, the geometrical figure created is an ellipse. It is not a circle. And the cutting is from one side of the cone to the other side of the cone. The figure that is created is an ellipse. Meaning to say, it's a curve, it's an oval shape, but not a circle. So that is how ellipse is created by the intersection of the cone and the plane. Okay, let's move on. Now, it says in here, when we say ellipse, it is actually the locus of all those points that is in a plane, such that the sum of their distances from two fixed points in the plane is constant. Now, before we're going to explain all those properties that is written in the definition of this ellipse, now we need to locate the two fixed points. So what if we are going to say that this point must be considered to be one of the fixed points? Another one would be this one. Okay? So we have in here two fixed points, and that the fixed point that we are talking in here are called the foci. Okay? Foci. When we say foci, that is a plural form of focus. Now notice that when we are talking of the parabola, the fixed point in there is focus, only one. But in here, in ellipse, we are talking of two fixed points. And that when we have two fixed points, we are talking of the foci, two focus. Okay, so we have in here the focus 1 and focus 2. Now, it says in here, when we are talking of ellipse, this is actually the locus of all points. So meaning to say, what we mean when we say locus of all points? Those points that creates the ellipse, so that when we are going to at least identify one of the point or another, we talk of another point in here, so that when we are talking of at least two fixed point, now we see our point is point A, another one would be point B. Now, there is called the sum of their distances. Meaning to say, when we are going to get this one, the sum of the distances of focus 1 to point A point A is constant. Meaning to say, when the sum is 3, all those sum will be 3. So that is the same as saying the distance of point A to focus 1, the distance of point A to focus 1 plus the distance of point A to focus 2 is constant. Constant. So that if I were to have also the distance of point B to focus 1 and point B to focus 2, I will say point B to focus 1 plus point B to focus 2 is still constant. Meaning, these points are located around or on the plane, or on this point A and B are located on the ellipse. So that in the definition, when we say the sum of their distances, the distances of point A to focus 1 plus the distance of point E to focus 2, the result will always be constant. Now, whatever result, shall I say, I computed 5, that result will also be the same as when I'm going to get the distance or the sum of the distance of point B to point focus 1 plus point B to focus 2. That is the same as we have in here. So meaning to say, if I were to add, it is still constant, and then what is that constant? The result is still 5 units. That is the meaning. Okay, that is the meaning. Now another one, I have to put again another point in here. Shall I say we have in here point C. So that if I were to get the distance between point C to focus 1, point C to focus 1 plus point C to focus 2, still the result is constant. Okay? Constant. Okay? That is the meaning. Now, meaning to say, if assuming that what is constant in there, when we added this one, point A to F1 and point A to F2, the result is 5. That 5 units is the constant we are talking. Every time that we are going to have any points, I do not know where will you locate it. Now, meaning to say, if the points you located is connected to focus 1 plus the point you located connected to focus 2, still the result is constant. And how is that constant? It is still 5 units. Let's continue the definition of the ellipse. It says in here, when we say ellipse, it is the locus or it is the set of all points in a plane such that the sum of their distances from two fixed points in the plane is constant. Meaning to say, when we are talking of an ellipse, there is always a permanent or two fixed point. Now, what are these two fixed points? Okay, assuming that I have in here, the two fixed point in here is when I identify this one to be fixed point 1, this is my focus 1. And my fixed point in here is identified, that would be my focus 2. Now, notice that the fixed point are the reflection of each other. So, meaning to say, there is the property of reflection also in the idea of ellipse. Meaning to say, whatever distance that I have in here in focus 1 from the center, that would be the same as the distance in here from the center going to this focus 2. And as I said, these are called to be now the focus. Okay? So, focus. When we are talking of focus in ellipse, they are the foci. Foci because that is more than one focus. Okay? More than one focus. Now, another thing that we need to consider is in ellipse, we have what we call the major axis. The major axis in the ellipse in here is always the longest side or the longest axis. So, what is the longest axis in here? We have the x-axis. So, meaning, if I have to locate the major axis, my major axis is this part, okay? So, that will be my major axis, okay? So, I will label this one to be my major axis. Okay? So, ayan. Now, when we have a major axis, we do also have the minor axis. And what is the minor axis? It is the shortest axis that you can see in an ellipse. So, where is that? The y-axis. So, if I were to identify that one, my minor axis is, okay, we have in here, okay. So, ayan, that would be my minor axis. So, what is that? Minor axis. Okay? So, when we are talking of ellipse, there are two axes that we consider, the major and the minor axis. Now, notice that when we are talking of the minor axis and the major axis, meaning to say, there is what we call now the distance in here, okay? Distance in here that we need to consider. So, in our major axis, that is actually from this point to this point. And that is actually the vertex, okay? Another one in here, we have in here the vertex. Now, from the left side to the right side is actually our A, okay? So meaning to say, the measure of this line segment, or what we will now the major axis, is actually from this vertex to this vertex is actually 2A. So half of it is A. Half of it is A. So that is the measure of our major axis. Okay? So the measure of our major axis is 2A. Now what about the minor axis? The minor axis is from this vertex going down to this vertex. So meaning to say, the measure is the same. If we have in here to be 2A, that is the same as 2B. Half of it from this vertex going to the center is B. Another one from the center going to this vertex is B. So we have 2B. That is the same as in the major axis. So what would be the measure of our major axis? Our major axis can be considered to be 2A in relation to this illustration. Our minor axis is 2B in relation to this illustration. Now mind you class that when we are talking of the ellipse, there are two kinds of ellipse we consider. We have what we call the vertical ellipse and then the horizontal ellipse. When we say horizontal ellipse, the major axis is the x-axis. When we say vertical ellipse, the major axis is the y-axis. So that is how we label the parts of the ellipse. So what are the parts of the ellipse? We have what we call now the major axis. So from this vertex to this vertex, and another one we have the minor axis from this point going to this point, and that is our y-axis. That is considered to be our minor axis. Now, what about the measure of the segment? The measure of major axis? The measure of the major axis is 2A. Where is that? Where is the location of the 2A? We have in here, from the center going to the right, to the vertex, that is A. Another one, from the center going to the left, that is another as A. So, to add it all, we have 2A as its measure. Now, the same through with the minor axis. The minor axis is composed of the segment from the center going up to this vertex, and from the center going down to this vertex, and that is the same as B and B. So totally, it will give you 2B, and that is considered to be our minor axis. Now another parts of the ellipse is we have in here, at least we consider 4 vertices. Okay, we consider 4 vertices. So this one, vertex, that is another vertex. This is another vertex. Okay, and we have another in here. A vertex. Now, considering our vertices, what is their name? The vertex located at the right is actually what point? That is point, what is our x? Our x is in here, okay? In here. So we have in here the x. There is the measure of the x. So that is the same as for our vertex, that would be the same as what is the measure? That is A. And what about its corresponding y? Notice that this point is what? Correspond to the center, okay, horizontally, which is the point of origin. And so that is the same as 0. Now what about in here? What is the name of the vertex in here? Notice that there is again the measure. What is the measure? You can see that one is still A, but that A is considered to be negative A. Why? Because it is located at the left side. Okay, at the left side. And notice that this point corresponds to the point of origin horizontally. And so your Y is 0. Okay? Now what about the name of this vertex? Notice that there is a measure. Okay? There is a measure. Considering our Y. Considering our Y. Why? Notice that from this point going to this one, it has a measure, and that is Y. So that is what is the measure? That is B. Okay? That is B. What about the value of X? Still, this point corresponds to this point, the point of origin vertically, and so that is the same as 0. What about the name of this one? The name of this vertex? What must be its name? Still, it follows this one that the name is 0 and negative b. Why negative b? It is because it is located below the point of origin. Okay? Your b is located along y-axis but located below the point of origin, and that is the reason why that is negative. What about this one? Why is it positive? Because your B is located above. Okay? Located above the point of origin, which is located also along the y-axis, and so that is positive. So, ayan, as you can see, everything is being labeled. Okay? Everything is being labeled, and so you try to recognize, you try to go over with the labeling, so that when we are going to touch the calculation, these things are very much important. Okay? We need them. We need them as our foundation when we compute the standard equation for an ellipse.